All right, students, I wanted to take a couple of minutes to make a video for those that need to go back over our lesson from today. We are discussing concentration of solutions, and we want to talk specifically about how to calculate when discussing concentration. We've already talked about how a solute is dissolved in a solvent, and that is an important feature in solutions, but chemists are not satisfied merely by saying some solute is dissolved in solvent. They want to know how much, and they want some values in relation to that. So, the word concentration is a word that talks about how much solute, what measured amount, is dissolved in a solvent. Now, two general terms that are commonly used are dilute and concentrated. Now, if you look at the picture I've chosen here, a dilute solution is one with a little bit of solute in it. So if I was to begin dissolving some cobalt chloride in water, and I put just a little bit in and stirred it, it might look like the diluted example on the far left. But as I go and I begin to move toward situations where, say, I put in, 1 gram here, and I added, and now I have 2 grams and 3 grams and 4 grams and 5 grams of solute dissolved in my cup. The more I have, the more concentrated the solution is. And you notice here that the colors are also changing as those solutes are dissolving. Okay, so concentrated means having more solute in it. So if you've ever made lemonade with the powder, and you've added a little and stirred it and tasted it and said, oh, it's too sour, or I need more, it's too weak, you have made a dilute solution. Whereas the more you make, the more you add, the more you stir, the more you add, eventually it will get very strong or concentrated, and maybe even too strong for you to drink, sweet or sour, and you need to add more fluid, more water to balance it out. I think you know what I'm talking about here. So again, I said, chemists are not satisfied with general terms like dilute and concentrated. Now, they'll typically want to have terms where they get exact number values for what concentration is. And so one of those units that are used is called molarity. Now, molarity is a value that expresses the concentration, solute, in the solution in a unit called molarity, which is big M. So big M means moles of solute in liter of solution. So if you were to write it as a formula or an equation, it would look like this. It would look like this. Big M equal to moles of solute over liters of solution. So it basically has to do with how much solute is in the solution. It's a way of expressing that. All right, let's do an example problem here. And I want to show you so that you can see how to do these problems yourself. So here it is. Here's our example. Let's read it through and then let's go ahead and calculate. What is the molarity? So I am looking for the big M, this one here, of a solution with 2 moles. Now this is a given. I want to keep track of that. That's a given. And this is a given. 2 moles of NaCl in 4 liters of solution. All right. Now my first step when I solve these problems is to write out the equation always, this one here, for molarity. So I'm going to put big M, that's the symbol for molarity, equals moles of solute over liters of solution. Solution is abbreviated SOLN for short. So I'm going to plug in or substitute the givens that I have here into this equation. So I'm going to plug in. I don't know the molarity. That's my unknown. So I'm going to leave that as a variable M. I do know the moles. it says it has 2 moles. So I'm going to put 2 moles in the spot where the moles go. And then on the bottom, I'm going to put 4 liters. Okay, those 2 are my givens. They gave them to me. I can substitute or plug them in. So I'm plugging these in. And once I plug those in, I do the math. So when I do the math, I'm going to take the 2 and divide by 4 because they are divided by each other in the equation. So as you know, 2 divided by 4 is a half or 0.5. So guess what? M equals 0.5. And that means 0.5 M. 0.5 M is the answer. M, remember, is moles over liters. It's automatically that, but the unit that we call it is M now. M meaning molarity. So there's the first one. Very easy one I wanted you to see. Now I'm going to give you a second one here, and I want you to try it yourself. So stop the video, try it yourself. It's just like the one I just did. And then I'll go ahead and solve it for you. All right, I'm going to solve it, so I hope you tried it yourself. As always, the first thing I'm going to do is write out my molarity formula or equation. Big M, which stands for molarity, equals moles of solute over liters of solution. Always write that out and then substitute in what your givens were. So remember, I told you reading it, it says, what is the molarity? Don't know it. With 3 moles, that's one of my givens, and 2.5 liters. So I'm going to go M equals 3 moles over 2.5 liters. And now I just need to divide. So I'm going to put into my calculator 3 moles divided by 2.5 equals. 3 divided by 2.5 equals M equals 1.2. And the units are M, okay, molarity. So I have my answer 1.2 molarity. Remember, molarity, don't forget, equals the moles of it over the liters of it. It's understood to be a way to know how much solute is in a solution. So of the 2 I just did, the one before this and this one, which of these solutions would be stronger when I look at their answers? 0.5 and 1.2. If they were the same substance, the 1.2 is a stronger solution, more solute dissolved in it. Let's see what you can do with this one. Try it on your own first and then watch me solve it. Start with your molarity formula. Try it on your own. Okay, here I go with the solution, the answer. So I want to first write my molarity formula. Moles of solute over liters of solution. And the reason why I know it's a molarity problem is because I see the word molarity, or sometimes you will see the word big M or the symbol big M. That tells you it's a molarity problem. So now I'm going to go through. I don't know molarity. I do have a given of 3 moles, and I do have a given of 250 milliliters. Those are my givens. All right, now you might want to pay attention to this because you notice moles go on the top, right? And liters go on the bottom. And I don't know the molarity. So I have a little problem right now. I hope you've noticed. These milliliters don't have a place. I need to change these milliliters and convert them. I need to convert it to liters before I can plug it in. Why? Because this requires liters on the bottom to substitute it into the equation. So before I can do that, I need to take the 250 milliliters. I'm going to set up a quick conversion factor. This is something we learned to do before. If you remember, King Henry died unexpectedly drinking chocolate milk. So now I just need to remember how many milliliters equal how many liters. Liters is here and milliliters is here. And they are 1, 2, 3 away from each other, which means 10 times 10 times 10 or 1,000. Milliliters are smaller. The smaller ones are always on the right and the larger ones are on the left. And remember, they differ by 10 each time I move, so it's 10. Whoops, what happened there? It's 10 times 10 times 10. That means 1,000. So I need to take that 250 milliliters divided by 1,000, which means move the decimal 1, 2, 3. So guess what? 0.250 liters is what's going to go up here to finally solve it. So in order to find my molarity this time, I need to take 3.03 divided by 0.25 equals. And I hope you guys got your answer of 12 m, 12 molarity. That's a much stronger solution than the one we had previously, which was 1.2. The bigger the number, the more strength. All right, one more problem for you to try. I hope you've been working your way through these with me. Here's my last one. Now, before we get into this one and I have you work on your own, I want to point something out. How many moles of solute? This one's different because we are looking for the moles of solute and the liters and the 0.1 m are given. So when you go into your molarity formula, I want you to pay attention to the fact that this is a different kind of problem, slightly different than the ones before. So stop the video, go try it, and let me come back and show you how, but hopefully you'll get it right. Okay, I'm going to go ahead and show you how now. So how many moles of solute? So guess what? I have M, and M is the big M. So I'm going to substitute or plug in the 0.01 M for the M. And I'm going to substitute or plug in the 0.250 into the liters because those are given. See what I don't have this time? I don't have the top, the moles. I don't know it. But the good news is, my friends, if you know a little math, you know that when there's an equal sign, you can cross multiply if you have two fractions. And I always have a fraction because I can put a 1. So I'm going to cross multiply and solve. So guess what I need to do? I need to do 0.250 times 0.1 for my answer. And it's going to come out to be X moles equals 0.025. So guess what? My answer is 0.025 moles. Why am I solving for moles? Because the given was liters and molarity, and they asked me to find moles. See that? So I did. Happy, happy. We did it. I hope that helps you guys. Keep on pressing forward.